Hello and welcome back to this class of chloralkali electrolysis what we are discussing. So, in that particular class already we have discussed two different types of electrolytic process. So, third type we will discuss now, which is the introduction of the membrane. So, introduction of the membrane within the electrolytic chamber will give you the third category of the corresponding electrolysis process for the chloralkali electrolysis, producing sodium hydroxide as a solution material which we get in the solution, and the two gaseous products chlorine and the hydrogen. So, diaphragm process what we have seen, the diaphragm technique what we have discussed, and that particular diaphragm technique is separating the anodes and cathodes. Now, the process what we are now seeing is, instead of your diaphragm, now we introduce a membrane. So, membrane is basically another finer material, another material which can have some obstruction for permit some of this material, because we all know that membranes can be semi permeable, we consider is as the semi permeable membranes. So, which can permeate or can allow to go some of the species through that particular membrane and others will be retained. So, in this particular process, that membrane process, you should know very clearly the typical process by name, the definition. Maybe some of these processes are outdated, we may not continue, because some of them are not so useful and is energy extensive also, like your first process, that mercury process, that mercury electrode process. So, day by day we can have some improvement, newer techniques will come, but the original process what is involved for the electrolysis is still remains. Only thing, the challenge is always there for the industrial sector is that how to produce the material at a low cost. So, the old materials and old processes are outdated, we should go for the new techniques, but the material still available, because we are talking in terms of typical inorganic materials as your bulk material or the commodity material, that will not change. Only thing that how easily and how quickly we can get the material at a cheaper way. So, you have now two chambers. So, now we are talking like that of your cathode and anode. So, you now have the cathode and the anode chambers, which will be separated by a water permeable ion conducting membrane. So, you should be knowing now that what are the typical definition of these. That means, as I told you that it is semi permeable one. So, what is that semi permeability of that particular material? Earlier in case of asbestos we have also seen that it is only allowing the liquid to pass, but it is not allowing the gaseous material to pass. That is why two different chambers for the two gaseous material what we can have. So, is water impermeable one. So, ion conducting membrane. So, if we now allow the membrane attached to it, which will not allow water to pass, that means whatever hydroxide ions if you are able to produce will not be allowed to mix with the sodium, and then how you get the sodium hydroxide. So, that we will see now that you have the pure brine water and you get this as the corresponding one, that means you have the membrane in between. So, you have the cathode and the anode sides there, and this cathode and anodes we can get. Therefore, for the introduction of the pure brine at the bottom, and as the electrolysis process is going on, your amount of sodium chloride is going less and less, and at the end basically this particular one is taken out. So, the solution which is less concentrated with sodium chloride is your depleted brine, that means less concentrating, we are less concentrating our material in terms of your sodium chloride, and by that time through the side of these two electrodes you get chlorine and hydrogen, and also through the production of this hydroxide ion with this water you get with this particular chamber. That means your the chamber on the right hand side will be responsible for producing your sodium hydroxide, unlike the two other techniques. So, if you just simply study these three techniques you should be able to compare these three techniques and where your sodium hydroxide is being formed, and if the flow chart is given to you, you should be able to recognize or identify that this flow chart for the cell is basically not even 3-dimensional drawing, is the very simplest one, is the block diagram we call, or the flow chart we call. So, the flow chart basically will tell you which particular process we are talking about, because sometimes if we not give this membrane to you, that is membrane is not given to you, because otherwise it will be quite obvious that you will be able to recognize it as this is meant for the corresponding membrane process. But the orientation of this thing and the production of the sodium hydroxide from one particular chamber towards the right hand side will immediately tell you that this is a membrane process through which on the right hand side, on the top you get the production of your hydrogen gas, and on the side you will be getting your sodium hydroxide solution, and which is less concentrated with respect to your sodium hydroxide, sodium chloride also along with your sodium hydroxide, because this sodium will go and pass through this particular solution and this water is not allowed. So, only sodium ions, that is why it is ion conducting membrane, or is which is water impermeable. So, ions are moving. So, sodium ions will move and reach over there, will go for its reduction. So, this anode material will be therefore responsible for the reduction of your sodium also, and that sodium will react with this if it is not reacting directly with your hydroxide ion. So, this sodium can go and react with hydroxide ion producing your sodium hydroxide, or the potential what you can set is not allow you to reduce this particular electrode to get you sodium as your sodium reduced form as sodium 0. So, what you get that this particular membrane and your membrane, the stability of the membrane is also important, because you are handling a very high sodium chloride concentrated solution. So, concentration of sodium chloride is pretty high. So, the material should be stable under high concentrations. So, your membrane material, it should be a polymeric one. So, polymeric material which you will not be able to attack it with a high salt concentration, and there will be a high pH jump between anode and cathode chamber, because you are producing more number of hydroxide ions, because hydroxide ions are getting accumulated over there and hydrogen ions are getting reduced to produce your hydrogen gas. So, you have a strongly alkaline solution on the right hand side or the right hand chamber. So, your material for the preparation of the membrane should be such that it should withstand a very high pH, that means the alkaline pH, and there is a pH jump between anode and cathode chamber. So, the membrane what is there, so on one side you have a pH of different type compared to the other side where pH is going up for the production of sodium hydroxide, and strong oxidizing agents like chlorine and hypochlorite, because the chlorine is also producing. So, it is a very drastic condition. So, industrially all these things always try to remember that when a industry is formed, there can be, if certain amount of negligence or neglect is there, it can have a typical disaster. So, industrial accidents are quite obvious, that is the reason, because the thing what you are handling is highly in all respect, that is highly concentrated, highly in alkaline medium, and your pH difference for these two chambers are very high. Sometimes it is doing that a high reaction temperature also. So, you should always be very much careful, because the huge amount what is being used. So, here you see not only the high salt concentration of sodium chloride, you have a pH jump from one chamber to the other. So, your membrane should withstand these two, as well as it should not be oxidized by the chlorine what is being produced, and the hypochlorite, which we all know is bleaching agent, and the bleaching function is only originating from its high reactivity. So, chlorine is the highly oxidizing agent, hypochlorite is also highly reacting agent or highly oxidizing agent and is also a bleaching agent. So, these two are highly reactive. So, in alkaline medium, the available chlorine and little bit of hypochlorite, as we have already discussed, that some amount of hypochlorite in presence of sodium hydroxide will be formed through the reaction of chlorine gas and sodium hydroxide. So, all these things should give us a useful membrane which can be utilized for this purpose. So, what is that? So, material should be perfluorinated polyethylene main chain. So, polyethylene main chain we know, that is the polyethylene chain we know, like that of your Teflon material, already we have discussed earlier while we are considering the fluorine and its usefulness for making new material or useful material for industrial point of view. So, perfluorinated, that means all the CH bonds will be replaced by CF bonds within the main chain, and only thing you have the side chains with sulfonic acids and or carboxylic acid groups, because you have to make it ionic, that means it is ion selective material or ion selective membrane, because it can take care of the sodium ions. So, if you use sulfonic acid which is negatively charged as the anion, the sulfonic acid anion SO3 minus, or the carboxylic acid end, the CO2 minus end. So, that can take care of large amount of sodium ions in it. So, that is why it would be a ion selective membrane. As we all know that there are some electrodes which we consider as the ion selective electrodes. Similarly, this particular case, these are ion selective membrane. So, these two are commercially available thing, one is the Nafion, another is the Flamion. So, the name is also is a commercial name because it is typically a trade secret, it is patent protected also. Sometimes the material is introduced, people even do not know what material is being used. Even the other company or other industry which is the competitor of the first one will not go for knowing this particular material. Since these are pretty old one and is basically now it is a textbook knowledge and is a knowledge to every students that what DuPont was using as a Nafion, because in the trade name of Nafion this material is available. Some company, also the chemical company, the polymer company, they are making this Nafion to the people for other purpose, not for this purpose only. But sometimes the need, basically the need of using this particular membrane material, you can have a good research and development activity for that particular purpose, for making or developing a new material for this particular purpose. So, that way the company is your DuPont. So, DuPont was responsible for making this Nafion and it is patent protected, and all you know that when some material is discovered or the research item what is being published not in the regular academic journal, but you can publish it in the patent or it is the patent protected item, and that patent protected item can have some lifespan only. So, it can have a 10 years or 20 years of patent protection. After that it can come to a general knowledge, it can be your textbook knowledge or people can know by that time what people are using. So, by two names basically, because simultaneously two companies, the two competitors can do together the development of this particular material. So, other one is Flamion, the name is different, but the material is same. But the second one, if we consider that first people have identified as the sulfonic acid functionality, the second people can use it as a carboxylate functionality, only little bit different in their corresponding activity or the corresponding effectiveness for the material for that particular purpose. So, Asahi Glass GLASS, this is SS, the Asahi Glass and the DuPont, they are making these having a typical backbone. So, you have perfluorinated polyethylene backbone like that of your Teflon. So, you have and you can have a side arm which is ending with a sulfonic acid or the carboxylic acid side chain, but you can see that there are some ether oxygens also. So, ether oxygen placement within the backbone also giving you some material characteristics or some flexibility in it. So, in terms of your understanding that how you define or how you tell about people about this membrane is that it is a perfluorinated material of different length, is the N value and N value in the polymer chain is also known. And on the M side, the M end, you have one particular carbon, you have the arm over there. So, how many N and how many N and how these two things are repeated along the chain is also known. You have the ether backbone over there, and at the end basically you have the corresponding ion sensitive groups, that means your carboxylate and the sulfonic acid groups. And the chambers what we are using, the cathode and the anode chambers are separated by this particular membrane. and you have the anodes which are titanium anodes, or cathodes are still as well as the nickel cathodes. So, stainless steel or the nickel cathodes are used, and as a result of using this membrane, sodium ions travel from anode chamber to the cathode chamber. So, that allowance is giving, that is why we are able to get sodium hydroxide production from a particular chamber and is being accumulated, and the advantage of this particular technique is that the purity of your sodium hydroxide produced in this fashion is increasing. So, very high grade of sodium hydroxide is being produced. We can consider it that if you exceed some level, you can consider it as the corresponding analytical reagent or a guaranteed reagent for sodium hydroxide. And the recommended cell voltage, which can give you very useful production of this material, is about only 1.15 volt, not much, and the optimum current density is about 4 kilo ampere per meter square. So, the current density is also very important to know that how much current is being passed at that particular voltage, which is pretty constant. So, it is a constant voltage electrolysis technique, and the current density is also should be known, and the electrode separation is not much, very fine separation is only 2 to 5 millimeter apart. You can put the electrodes together, only thing that you can have the membrane barrier. So, this barrier is important. So, electrolysis in membrane cell consumes significantly less electrical energy than mercury cell. So, that is the major advantage what we are moving one after another on. Elaborately, we are discussing 3 different techniques, and this particular technique has the great advantage because the cost of production should be less if you are using less amount of energy as your electrical energy for this particular purpose compared to the first technique. So, this particular membrane process has some advantages. So, the last technique we are not considering all comparison, that means the first with second, second with third and third with first, that is not the thing. Only thing that what is the most useful one which can be utilized for different purpose, because that brings you the understanding of the introduction of the membrane, because the membrane we use so many places, because the membrane is also nowadays a very good area of understanding, good area of knowledge and good area of research and development. When we talk about the corresponding osmosis process, the reverse osmosis process, there we also use some amount of membrane. In a high pressure, we go for the separation of the unwanted ions from our drinking water. So, you have the advantage of the production, some of these advantages. Definitely all processes may not have only the advantages, you can have also certain types of disadvantages for this particular process. So, what you get, the purity of the sodium hydroxide is very high. So, you get pure sodium hydroxide, and what you get as already told you, that is a lower consumption of electrical energy than the first process, and no utilization of mercury or asbestos which are environmentally harmful, because nowadays some of these techniques basically are banned. So, industry people are facing lots of trouble to get the environmental clearance. So, if it is not helping or if it is destroying our environment, then that particular procedure, whatever good it is, will not be allowed to run for the industrial sector. So, industrial sector, the first thing is that they should have the useful clearance from the environment department basically. So, environment protection agencies are there. So, these two things, the mercury is a very bad material for contaminating your environment. Similarly, asbestos is also a very bad material because it goes to our lung and it can considered because it is basically a silicon material. So, silicosis is the disease which the people working on making this asbestos. So, we should reduce the use of asbestos day by day, because it is earlier it was a typical building material for making our roof, asbestos sheets basically, like our steel sheets or the tin sheets. We were using the asbestos sheets because at that time probably our country was not so rich, we cannot afford, because we can afford the asbestos only that time. So, making of all these asbestos, including the use of this asbestos as a material for electrolysis, has been totally stopped. So, we can have only the development on this membrane process, and if we just simply follow the history of this particular development, that how it has been developed, you will be tempted to develop further, because you have to go ahead with the further development of that particular process from this membrane technique. So, if you have now in your hand the membrane technique, how you can go further to improve this particular technique in terms of the membrane material, in terms of electricity consumption, in terms of designing the electrolysis chamber and all this. So, the disadvantages. So, definitely the new technique will improve, is the improved technique, and which will also eliminate the disadvantages what you can follow for this particular membrane process. So, one of the major disadvantage is that only up to 35% by weight content of sodium hydroxide will be able to produce by this particular technique. So, you have to go for concentrating more and more amount of the volume bulk what is being produced from the electrolysis cell, but this is not a very bad amount, but is not very high, that means it is not above 50% as a yield of a particular material, because the industry always looking for certain amount of production, because you have the production cost and the production technique and manpower, all these things are related. So, people are happy in industrial sector that if you are able to produce something above 90%. So, yield, if the yield is 90%, they are very happy. Then the produced chlorine gas, because some amount of this production will also contain the oxygen, as we all know that the electrolysis of the water, because we are adding water to the system. So, electrolysis of water can give rise to the production of hydrogen as well as oxygen. So, you cannot eliminate until and unless you change or to design the new electrode type, new electrode material, you cannot avoid the contamination of the chlorine gas by the corresponding oxygen available through that particular oxidation of the water molecules. And very high purity of brine is required, because the supply of the raw material, if you spend more money in improving the purity of the brine, it will not be that much cost effective for the industry. So, always you require a very high purity brine. So, the other two techniques what we have discussed, those two techniques can handle the low grade brine material. So, that is one of the obstacle for this particular technique. Then high cost and limited lifetime of the membrane. So, basically is a very cost, is not a cost effective one. So, it is a costly affair in terms of the different types of membrane, until and unless the polymer industry can help you in making these two membrane at a very cheaper way or at a very cheaper price. So, the cost of the membrane is also a disadvantage for this particular process, and as a result what we can do for this particular one, that you can save the electrical energy, still people make it for these. The most economical one for the chlorine manufacturing process is the most economical one, and for the investment in new plants. So, if you save the money, you can go for the investing a new plant, or you can utilize the produced chlorine, because we are getting chlorine out of this. So, you can utilize that chlorine basically for making new types of material which are value added. So, applications. So, these two components also will see the application wise, this application of chlorine as well as the application of sodium hydroxide, because much lesser amount of hydrogen as gas is produced through this particular methodologies. So, we will not discuss for that only, because hydrogen usefulness is nowadays we know, but you have to produce a huge amount of hydrogen out of water or out of any other technique. So, that hydrogen can be utilized for the as a useful fuel also. So, application of chlorine will tell that the first one, the chlorine. So, chlorine as we know is a very good oxidizing agent, and it has a corresponding oxidation potential also very high, which is 1.35 volt. So, if we can bleach some paper and the pulp material, the bulk material for the production of the pulp and the paper bleaching cases, the pulp for making the paper, it is very much useful because it can bleach for the whitening, basically a little bit of whitening of those material, the starting material for making paper, and it is useful for the manufacture of the corresponding chlorohydrocarbons on the decline. Once we write, because long back we were utilizing this, a huge amount of this is being used for bleaching purpose as well as making the chlorohydrocarbons, as well as also the chlorofluorocarbons, the chloroform, the dichloromethane, the carbon tetrachloride. These are all different types of chlorine bearing solvents and the reagents and organic compounds. But the demand is declining because again these are harmful for the environment. So, mostly where we can use selectively, we can choose all these things where we can utilize, because the use of those materials and the demand in the market is also very important. So, making of your PVC is there. So, polyvinyl chloride preparation, so again is a chlorine based material use. Then CC chlorination, that means the chlorination of the different organic compounds, whether you are using a pharmaceutical compound or a medicinal compound. Still we are using pulp bleaching, but if you can go for the corresponding consideration that is at a low concentration, then making of the propene oxide, water treatment, phosgene for isocyanate preparation. So, these isocyanates are having a huge demand in industry. Then making of chlorobenzene, alkyl chlorides and titanium dioxide bichloride processes, because there are some processes which are involving the use of chlorides. So, those chlorides can come from your typical Cl2 gas only. So, more use is expected in the manufacture of the first type, that means the matching and the manufacturing of the PVC, and the other one, that means the phosgene, that means the phosgene for isocyanate manufacturing. Because we know that the Bhopal gas disaster, what has happened due to the formation or the storage basically methyl isocyanate. So, for the agriculture industry, for making the insecticides and the pesticides, all these things, this is a very good starting material. That is, if you are not going for making the MIC, the methyl isocyanate, but some other isocyanates, it is going through the phosgene, which is COCl2. The phosgene preparation is also dependent on the industry like this, that means the chlorine industry. Then the industry which we are looking for your sodium hydroxide. So, sodium hydroxide is being used starting from your typical academic lab, our teaching lab, to research and development area, everywhere. And lastly, to so many industry, sodium hydroxide is required, because you in a cheaper way, like sodium chloride as a table salt, the sodium hydroxide you can use in a cheaper way to maintain the corresponding alkaline medium or the alkalinity of the corresponding process. So, different chemical processes are benefited by the use of this particular sodium hydroxide, what is being produced over there, and mainly it is utilized for the neutralization or as an alkaline reaction medium for different types of reactions, and in large quantities still it is used in the pulp and the paper industries and in the manufacture of aluminum, as we have seen earlier, that we can use this in the manufacturing of aluminum, where we use that particular one, that is for the corresponding formation of aluminum hydroxide formation from your bauxite or any scrap aluminum. So, formation of this aluminum hydroxide, because that can be converted to aluminum trifluoride and then to cryolite, we have already seen these processes. So, the sodium hydroxide requirement or the demand is very high over there for your production of this aluminum through the electrolysis of the cryolites. So, this sodium hydroxide will be utilized for making large number of organic chemicals also, because the different types of reactions in the alkaline medium at a very high pH value, you require the sodium hydroxide as the most favored and the cheapest medium for this reaction compared to your other hydroxide medium like potassium hydroxide or any organic bases like tetraethyl ammonium hydroxide or tetramethyl ammonium hydroxide. So, It is the most cheapest alkaline organic medium which can be provided to you for the reactions. Then large number of inorganic chemicals, whether you are getting some sodium based compound or the hydroxide based compound, you require sodium hydroxide for the production of inorganic chemicals. Then as I told that pulp and paper industry, aluminum industry and the textile industry is also useful for that. And then finally, the detergents and the different cleaning agents are also utilized for these particular processes. That means where we use sodium hydroxide for making detergents and the different types of cleaning agents. So, that gives us a very good idea that how the chloralkali process can produce so many useful chemicals and which can further be utilized in different industrial sectors, because this can be utilized in different areas. Okay. So, thank you very much.